Hey guys, today's video is on systems of equations. What these systems are, they're basically two or more linear equations that we're going to write. And when we graph basically two or more linear equations, we're looking for their solutions. And there's three types of solutions. You can have one solution where you have a line and then another line and they cross at one point, and that's your solution. You could have no solution if the two lines that you graph do not intersect, so there is no ordered pair where they cross. Or you can have infinite solutions where one graph, one line, and the other line are actually on top of each other, so there's an infinite number of dots that they share. We're going to solve systems of equations three different ways. Today we're going to focus on two of the ways, graphing and substitution. Both of them you should have learned last year. Let's solve number one by graphing. All you have to do is take your equation, which might or might not be in slope-intercept form, and graph it. So number one, we go at -6, and then a -5/3 slope. I'm going to keep going. And then you draw your line. And then the other graph has a 5 y-intercept and an up 1/6 slope. And then you'll draw that line. And hopefully they do cross at a nice point, and they do. They cross at this point right here. So you write your solution as the ordered pair, -6, 4. Let's do another one. Let's do number two. This one's already in slope-intercept as well. The first one, y equals 5, looks like the horizontal line at 5. And then the other graph, y equals 2x plus 7, cross at 7. And you're going up 1/2, just like that. And they cross at the point -1, 5. Sometimes your equations will not be in slope-intercept form. So all you have to do, is convert them into y equals mx plus b. Like all these problems, you don't have to worry about flipping any signs since they're all equal signs. So make sure you set these equal to y equals before you graph slope-intercept form. Let's do solving by substitution. When we solve by substitution, follow these steps. You're going to solve for one of the equations for either x or y. That means isolate the variable. Doesn't matter which one you do. Next, you're going to substitute the resulting equation from one into the other equation and then solve. Let me show you what this looks like. Looking at number 7, both of these are already solved for a variable, but we only needed one of them, so it doesn't matter. So we don't have to worry about step 1. That's done. One of them is already solved for a variable. Then we're going to substitute. So I'm going to take the -7x minus 1, and I'm going to substitute it in for y into the other equation because that's what it equaled. It's y equals that. And plugging it in into the other equation, I get -7x minus 1 equals this part right here, x minus 9. Now I just solve for x. -8x equals -8. So x is going to equal a +1. So we substituted and then we solved. The last step is to substitute to get the y value now. I'm going to take x plus 1, and it doesn't matter, x equals 1, it doesn't matter which equation you plug it in for. I'm going to plug it into the second one because it looks a little easier. And you get y equals 1 minus 9, y equals -8. And remember, you always write your solution as an ordered pair, x comma y. So this system was crossing out one point at 1 comma -8. Let's do another one. 9. Let's see. It is not in solved for variable. Both of them are in standard form. So between the 6x, the -5y, the 7x, and the y, think about which one of these would be easier to isolate. It'd be easiest to isolate this y here, to solve it for y equals -7x plus 22. And after we isolate one variable like we just did, we can substitute that quantity into the other equation. And for y, since it was y equals. Now I'm going to write that first equation over, but instead of instead of y, I'm going to write what it was equal to, -7x plus 22. So basically for substitution, we're just taking an equation that has two different variables and making it have one. Now to solve, believe that's -110 equals -28. Combining like terms, 41x equals +82. Dividing by 41 gives us x to be 2. And then we substitute this in for any of the equations. I'm going to plug it in for this one because it's already solved for y. I have to do a lot less work. Plugging it in, I get y equals -7 times 2 plus 22. Y is going to equal -14 plus 22. Y equals +8. And your final answer is an ordered pair, which is 2, 8. Let's do a problem where we may have an infinite or no solution. Let's do number 11. Let's see if that one gives us a special solution. So first, let's see between the 2y, the 6y, the 3x, and the -y, what would be easiest to get by itself. You don't always have to pick y. Just for this video, it seems a couple of them have been y. You can choose x if it's easier to isolate. I'm going to get this y by itself by dividing everything by 2 on the top. So y equals 3x plus 5. Again, I got that by dividing everything by 2. Rewrite that 5. And then I'm going to take that quantity and plug it in for y in the other equation. I'm left with 3x minus, big mistake here is not putting parentheses. So please make sure you, when you substitute, always put parentheses when you substitute. So we got 3x minus through the distribution. It's 5 equals 5. The 3x's cross out, so we have -5 equals 5. Whenever your variables go away, you look at your final statement. Is this a true or false statement? Does -5 equal 5? That is false. So you say there's no solution. If it was true, you would have said infinite solution. What a no solution means is that your lines are parallel. They do not intersect. They have the same slope. Write down what questions you have on graphing or substitution. We'll do a lot more practice with this next time, and have a great night.